If you've ever had to manage a Linux system, you know that when things go wrong, the logs, well, they're your best friend. They tell you the story of what your system is doing, what it's done, and where the skeletons might be hiding. But that story isn't written by just one author. It's a team effort. And today, we're going to pull back the curtain on that whole process.
So, you run a command, something breaks, and a log gets written. Simple, right? Well, not exactly. The journey that single log message takes from the moment it's born to where it finally rests is actually a pretty fascinating pipeline, full of specialized tools. And understanding that pipeline, that's what separates a good troubleshooter from a great one.
On any modern Linux system, logging isn't just one program doing all the work. Think of it more like an assembly line, with 3 key players, each with a very specific job. So let's meet the crew that handles every single message your system spits out. First up, you've got systemd journal D. This is the collector right at the start of the line, grabbing everything from everywhere. Then our syslog steps in. It's the sorter, taking all those messages, filtering them, and packaging them into nice, easy-to-read text files. And finally, you have logrotate, the warehouse manager, who makes sure all those packages don't pile up and crash your server. All right, let's start at the very beginning of our pipeline with the first and maybe the most important component, that universal collector, systemd journaled. This is where every log message begins its journey. So what makes journaled so special? It's all about that structured binary journal. See, instead of just writing plain old text, journaled treats logs like entries in a database. It vacuums up messages from the kernel, from boot events, from the standard output and error of all your services, and puts everything into one central, super efficient place. And that binary format, well, that's journaled superpower. Every single log entry gets tagged with all this juicy metadata, like the exact service name, the process ID, the user ID, and it's all indexed for lightning-fast searches. Now here's a crucial tip. If the /var log/journal directory exists, your logs will be stored there forever, or, until you delete them. If it doesn't exist, they go into /run/log/journal, and poof, they're gone on the next reboot. So if you want your logs to stick around, make sure that directory is there.
So how do you actually read these special binary files? You can't just cat them. Nope, you use the journalctl utility. And this is where you really see the power of all that metadata. With one simple command, you can say, hey, show me everything from the SSH service that's happened since midnight. Just try doing that with grep on a giant text file. It's a game changer. You can even create your own logs just to test it out using a command like systemdcat, echo hello journal.
Okay, so if journaled is so awesome, why do we need anything else? Great question. For all its power, a binary log isn't always what you want. A lot of admins and a lot of tools are just used to dealing with simple human-readable text files. And that is where our next worker, our syslog, comes into the picture. The key difference is right here. Journaled is all about collecting everything and letting you do these deep, structured queries. Our syslog is the traditional workhorse for creating those familiar plain text logs you see in /var/log. It's perfect for a quick look with tail or for sending logs off to another system. They're not competitors, they're partners, each playing to their own strengths. Now, this handoff happens in one of 2 ways. The old school way is for journal to just spray everything to a socket that our syslog listens to. But the modern, preferred way is for our syslog to act as a journal client. It uses a special module called imjournal to intelligently pull messages right out of the journal. This is way more robust because it makes sure no messages get lost, even stuff that happens super early when the system is booting, before our syslog is even up and running. Once our syslog gets a message, it checks its rulebook, which is /etc/rsyslog.conf. This is where the sorting magic happens. This rule on the screen is a classic. It basically says, hey, if you see any message related to authentication, no matter the priority, I want you to write it to the /var/log/off.log file. And this isn't just about local files. In a real DevOps setup, our syslog's real power is routing these logs over the network to a central log server, giving you one place to see everything happening in your whole infrastructure. Okay, so our assembly line is working perfectly. Journaled collects, our syslog sorts and packages everything into these nice text files. But what happens after a week or a month? Those files can get huge. We need that warehouse manager to step in and keep things from getting out of control. And that manager's name is logrotate. Its job is simple, but it is absolutely critical. Stop log files from eating your entire hard drive. It's a little utility that usually runs automatically every day, thanks to a cron job, and it just does all the housekeeping on those text files that RSysLog has been creating.
So what does rotation actually look like? It's pretty clever. Log rotate looks at the current off.log, renames it to something like off.log.1, and then creates a brand new empty off.log for RSysLog to start writing to. Then, to save even more space, it can compress that old off.log.1 into a .gz file. It'll keep a certain number of these old files around and then automatically delete the oldest ones. It's a brilliant, hands-off cycle of archiving.
And you're in complete control of this whole process through a few config files. There's a main one at /etc/logrotate.conf, and then specific rules in the /etc/logrotate.d directory. These directives are basically your instructions to the warehouse manager. You can tell it to rotate logs daily, keep maybe 7 of the old ones, definitely compress them, and even to just chill out if a log file it's looking for happens to be missing. It's incredibly flexible.
Okay, we've met each worker on the assembly line, we've seen what they do. Now let's put it all together and watch a single log message make its entire journey from start to finish. This is where the whole picture really comes into focus. So let's trace it. Someone tries to SSH into your server. That event is instantly captured by systemd-journal.dot and stored with all its rich metadata. Next, that log entry gets handed off to RSysLog. RSysLog sees it's an authentication message and says, aha, I know what to do with this, and appends it to the var log off log text file. That file keeps growing and growing until finally log rotate comes along on its daily schedule, archives it, squishes it down, and makes room for a new one. And that right there is the key takeaway. These are not 3 separate systems fighting with each other. They are 3 stages of a single, really elegant pipeline. You get instant, structured collection, you get human-readable sorting, and you get long-term automated management. They work together perfectly to give you a complete story of your system's health. By understanding how this pipeline works, you're doing more than just learning about some system files. In the real world, this local pipeline is often just the beginning. The logs that RSysLog creates are frequently shipped off to big centralized systems like the Elk Stack or Splunk. That's where they can be combined, put on dashboards, and used to trigger critical alerts. So now that you know how the story gets written, you can build the tools to read it across your entire network. The only question left is, what will you discover?